Can a moon vanish? The strange case of Iapetus. It may sound impossible, but one of Saturn's moons once appeared to vanish before astronomers' eyes. Iapetus, the third largest of Saturn's moons, baffled early observers by appearing one day, then disappearing the next. This wasn't an illusion. It was astronomy's version of a magic trick, but uncovering how it worked only deepened the mystery. Iapetus is a moon of extremes. One hemisphere is coated in brilliant reflective ice. The other is so dark it absorbs nearly all sunlight. Encircling its equator is a massive ridge, forming a giant, unexplained waistband that gives Iapetus a distinctive walnut-like shape. How did this bizarre moon come to be? The story begins in 1671, when Italian-French astronomer Giovanni Domenico Cassini spotted a new object orbiting Saturn. But this moon didn't behave like the others. When it was west of Saturn, it was visible. But once it moved to the eastern side, it faded or vanished completely. Cassini noted that even larger telescopes couldn't find it when it disappeared. He theorized that the moon must have one bright hemisphere and one dark one, and that it was tidally locked, always showing the same face to Saturn, just like our moon does to Earth. Cassini's insight was remarkable for the time. It marked the first detection of surface variation on a planetary moon beyond our own. Though he originally named the moon after King Louis XIV, modern astronomy follows John Herschel's naming convention, assigning it the name Iapetus, a Titan, and father of Prometheus in Greek mythology. For centuries, Iapetus remained an enigma, just a flickering point of light. When the Voyager probes flew by in the 1970s and 80s, they confirmed Cassini's idea of a two-toned surface. Voyager 2 also hinted at something stranger, a giant ridge along the moon's equator. But it wasn't until 2007 that the Cassini spacecraft, named after Iapetus's discoverer, provided a close-up look that revealed Iapetus's true nature. Cassini's flyby at just 1,640 kilometers from the surface showed a complex icy world. Iapetus has a low density, about 1.2 times that of water, suggesting it's composed mostly of ice with a bit of rock. Its oblong shape and equatorial ridge make it look like a misshapen walnut. There's no evidence of a subsurface ocean or active geology like on moons such as Enceladus or Europa. Its heavily cratered surface speaks of deep time, billions of years without significant change. Unlike Saturn's other major moons, Iapetus orbits far out, about 3.5 million kilometers from the planet, and its orbit is tilted by 15 degrees. This unusual orbit may hint that Iapetus didn't form in the same disk as the inner moons, or that it migrated early in its history. But the most striking feature of Iapetus is its surface contrast. Its leading hemisphere, the side that faces forward in orbit, is coated in a pitch-black substance known as Cassini regio, with an albedo, reflectivity, as low as 0.03–0.05. The trailing hemisphere and polar regions, in contrast, reflect over 10 times more light, as bright as fresh snow. No other object in the solar system shows such a stark dichotomy. The contrast is dramatic and sometimes abrupt. In equatorial regions, the dividing line looks almost drawn, while in others it blurs. Dark dust streaks spill into bright areas, and bright ejecta from impacts splash across the dark terrain. What causes this? For years, scientists believed the dark coating came from within, Iapetus spewing cryovolcanic material onto its surface. But Cassini data revealed that the dark layer is thin, just a few centimeters to perhaps a meter thick, and that bright material lies beneath it. Craters expose icy interiors, suggesting the dark stuff fell from above, not rose from within. Spectral studies in the early 1980s showed the dark material resembles carbon-rich meteorites, particularly the Murchison meteorite. This hinted at an external source. The best candidate? Saturn's outer moon, Phoebe. Phoebe is a small, dark, retrograde moon, meaning it orbits Saturn in the opposite direction of most other moons. It's likely a captured object, not formed with Saturn's other satellites. Over billions of years, collisions on Phoebe and other irregular moons created a vast, diffuse ring of dust, now known as the Phoebe ring. Iapetus, orbiting just inside this dusty ring, acts like a giant fly swatter. Its leading hemisphere collects the dark particles as it plows through the debris. This material settles on the moon's surface, gradually darkening one half of it. Once the dark coating takes hold, sunlight heats it more effectively than the icy regions, leading to a thermal process called sublimation. The brighter ice nearby slowly turns to vapor and migrates, reinforcing the contrast by making the dark areas darker and the bright areas even brighter. This combination of external dust and internal temperature-driven migration sculpts Iapetus's yin-yang face. Over millions of years, what started as a light dusting from Phoebe turned into the solar system's most dramatic contrast. And what of the equatorial ridge, the giant mountain chain that runs perfectly along Iapetus's equator, stretching over 20 kilometers high in places, higher than Mount Everest? Its origin remains a mystery. Some theories suggest it's a fossil from a time when Iapetus spun faster, pushing material outward at the equator. Others think it could be remnants of a collapsed ring or the result of cryovolcanic activity early in the moon's history. But no theory fully explains its symmetry or scale. Iapetus is a world that challenges our assumptions. Its strange orbit, dramatic surface, and unearthly ridge make it one of the most unusual moons in the solar system. It's a frozen time capsule, offering clues to Saturn's past and to the chaotic early days of the solar system. As we continue to explore, Iapetus stands as a reminder that even in a well-studied solar system, true mysteries remain. Can a moon disappear? The enigma of Iapetus. In the early days of astronomy, Saturn's moon Iapetus appeared to perform a baffling trick. Some nights it was clearly visible through telescopes, while at other times it seemed to vanish entirely. This celestial sleight of hand puzzled astronomers for centuries. But as we peeled back the layers of mystery, the story only grew stranger. Because Iapetus is no ordinary moon, it's a world of stark contrast, profound asymmetry, and bizarre geology. This distant moon has one hemisphere shrouded in near-total darkness, and the other gleaming with reflective ice. Around its equator winds a colossal mountain range, unlike anything else in the solar system. What forces carved this mountainous belt taller than Mount Everest? And why is Iapetus a moon of such extremes? Our story begins in 1671 with Giovanni Domenico Cassini. Using the Paris Observatory's telescopes, Cassini discovered a new moon orbiting Saturn. But this moon behaved oddly. When it appeared west of Saturn, it was bright and clear. But once it moved eastward in its orbit, it dimmed, sometimes disappearing from view entirely. Cassini noted that even with the most powerful telescopes of the time, the moon could vanish overnight. He hypothesized that Iapetus had one side significantly darker than the other, and that it was tidally locked, always showing the same face to Saturn, just like our moon does with Earth. This meant that as Iapetus orbited Saturn, it alternated. Which face was visible from Earth? When the bright side faced us, it was easy to spot. When the dark side turned toward Earth, it faded into the blackness of space. It was the first time surface features had been inferred on a moon outside the Earth-Moon system, a groundbreaking discovery for the 17th century. Cassini named his discovered moons Sidera Laodicea, stars of Louis, but the name didn't last. Later, John Herschel proposed mythological names for Saturn's moons, and Iapetus, father of Atlas and Prometheus, became the name of this peculiar world. For centuries, Iapetus remained a distant, flickering mystery. Even the Voyager probes in the late 20th century captured only distant images. Voyager 1 confirmed the stark brightness contrast. Voyager 2 provided slightly better resolution, revealing a massive equatorial ridge. But it wasn't until the arrival, the Cassini spacecraft in 2004, that Iapetus would truly come into focus. In 2007, Cassini flew within just 1,640 kilometers of Iapetus, giving us our clearest look yet. What it revealed was stunning. A two-faced world. Iapetus is made largely of water ice, with a density only 1.2 times that of liquid water, suggesting it's up to 75% ice. It lacks geological activity and likely has no subsurface ocean. Its surface is ancient and heavily cratered, particularly on the bright side. Its orbit is another oddity. Iapetus orbits Saturn at a vast distance, 3.5 million kilometers away, taking 79 Earth days to complete a single orbit. That's more than twice as far as Titan, Saturn's next major moon. Even more curious, its orbit is tilted about 15 degrees from Saturn's equatorial plane. These anomalies suggest Iapetus may not have formed in the same disk as Saturn's other large moons. But the moon's most striking feature is its visual contrast. The leading hemisphere, the side that faces forward in its orbit, is coated in a dark reddish-brown material. This region, known as Cassini Regio, reflects just 3% to 5% of sunlight. In contrast, the trailing hemisphere and poles are bright and icy, reflecting 50% to 60% of sunlight. This makes Iapetus home to the most extreme albedo contrast in the solar system. In some areas, the boundary between dark and bright is razor sharp, almost as if drawn with a brush. Elsewhere, it's more gradual, with craters scattering light or dark debris across the dividing line. The source of the darkness. So where does this dramatic contrast come from? Early theories pointed to internal processes, perhaps volcanic activity, that spread dark material across the surface. But Cassini's radar and imaging data showed the dark coating is a thin layer, often less than a meter thick. Impact craters in Cassini Regio expose bright ice beneath the darkness, indicating the material settled from above, not erupted from below. Spectral analysis revealed the dark dust is carbon-rich, similar to the Murchison meteorite. The leading hypothesis. The dust came from Saturn's outer moon, Phoebe. Phoebe orbits Saturn in the opposite direction, a retrograde orbit, and is coated in dark material. Impacts on Phoebe and similar moons have created a vast, diffuse dust cloud, Phoebe's, which stretches far into space. Here's where the Poynting-Robertson effect comes into play. Sunlight exerts a tiny force on dust particles, causing them to slowly spiral inward. This inward-moving cloud, traveling retrograde, slams head-on into Iapetus's prograde leading hemisphere, like bugs splattering on a windshield. The trailing side is largely shielded from this bombardment. But simple deposition alone doesn't explain the sharpness of the dark-bright divide. That's where thermal segregation comes in. The dark coating absorbs sunlight and warms slightly, more than the surrounding ice. Even a minor temperature increase can trigger sublimation, where ice turns directly into vapor. On Iapetus, with its 79-day-long days, The dark side warms enough for ice to sublimate and vanish. The water vapor then migrates to cooler regions, namely the bright, reflective trailing hemisphere and poles, where it recondenses. This creates a positive feedback loop. Dark areas get warmer, lose ice, become darker. Bright areas stay cool, gain frost, become brighter. Over eons, this cycle exaggerated the contrast, sharpening the border and deepening the mystery. The Great Ridge. If the black and white contrast were all there was to Iapetus, it would still be strange. But then there's the ridge, stretching more than 1,600 kilometers along the equator. The equatorial ridge is a wall of mountains up to 20 kilometers tall and 200 kilometers wide at the base. That's more than twice the height of Everest, running halfway around the moon like a stone girdle. It gives Iapetus a walnut-like shape, truly unique in the solar system. But what could have formed such a colossal, linear mountain chain? One leading idea is that Iapetus once spun far more rapidly than it does today, possibly completing a rotation. In just 16 hours, this would have created a pronounced equatorial bulge. As the moon cooled and solidified, that bulge may have frozen in place. Over time, as Iapetus became tidally locked to Saturn and its spin slowed, the bulge could no longer support itself and began to slump, piling up along the equator to form the ridge. Another theory suggests that Iapetus may once have had a ring system of its own. If a captured object or impact-generated debris orbited the moon for a time, it would have formed a ring aligned with the equator. Over time, that ring could have collapsed and deposited material along the equator, building up the ridge. This theory neatly explains the ridge's placement and its confinement to the dark hemisphere, if the collapse coincided with the influx of Phoebe's dust. However, it raises questions about how such a ring formed and became unstable. Other explanations, such as tectonic activity or internal upwelling, don't account for the ridge's perfect alignment or massive scale. Nor would a single impact produce such a symmetrical feature. Cassini's images show the ridge is ancient, heavily cratered, and seemingly made of crustal ice. Some sections have slumped or collapsed, suggesting it's slowly eroding. But its origins remain one of the solar system's great unsolved mysteries. What we know and what we don't. The Cassini mission transformed our understanding of Iapetus. It confirmed the theory of exogenic dust and sublimation as the cause of its two-tone surface. It provided stunning images of the equatorial ridge and mapped the moon's shape, surface composition, and gravity field in unprecedented detail. And yet so many questions linger. What precisely is in the dark material? Did Iapetus truly have a ring or submoon? What ancient processes carved its equatorial spine? No future missions to Iapetus are currently planned, meaning these questions may remain unanswered for decades. Until we return, we're left with tantalizing glimpses and a moon that still manages to vanish into mystery.